Who wants what?
26.
Sounds like a good one. Let's do it. Can you please tell me what 26 is?
It says an open box with a square base that is required.
Hold on, it went blank on me. I'm gonna go like this. Okay, 26.
It says an open box with a square base is required to have a volume of at least 10 cubic feet.
Okay, so volume. 10 cubic feet. Got it.
And then it goes through A through D.
Okay, A.
And then A says express the amount A of material used to make such a box as a function of the length X of the side of the square base.
Length X. Of side of base. Of side of base. Okay. So again, it's an open box, right, class? An open box has how many sides?
4.
One more time.
5.
5. Okay. Why?
The bottom.
That's the bottom, and 4 sides on the right. Would you agree? This is the box that we're about together. Okay. There are 5 sides. So let's talk about this material. In this question, they're using what variable for the material? A. So A in essence is just the what? A is material for the problem, but in essence is what? Area, right? Isn't it just area?
Yeah.
Of how many sides again?
5.
5. How do I find the area of the base? The base. Length times width. According to that, what's the length and what's the width? X, right? Because it's a square base. So is it the base X? So what's X times X?
X squared.
Beautiful. It's X squared, right? How many other sides now do we still have to find? 4 more. So here we go. Here's my box. Okay. What is this? I'm going to look for one side first. I'm going to look for this side. Okay. What is the material? What is this dimension? It's X, right? Do we know what the height is?
No.
Not right now, but that's okay. We'll write that down. We'll figure it out. Okay. So material, which is area, would you agree that it's going to be the base plus 4 sides? Okay. The base, according to the problem, is square. So the base area is X times X. Okay. 4 sides, one of the sides, okay, we talked about it. What are the dimension of one of the sides? X times height, right? We don't know what the height is, but that's okay. We'll figure it out. So they give you 10. That means what? What is 10? The volume. What is the formula of a volume of a box? Length times width times height. You're right. So length times width times height. Here's the length. What is this called in this problem? X. Here's the width. What is this called in this problem? Also X, right? So this is X times X. The height is still not known. Would you agree? All of that is still 10. X times X is X squared. Okay? So that's X squared times H equals 10. Can I solve for H so I can use it later in my area problem? Yeah, what is H? Yeah, just simply 10 over X squared and leave it. Okay? Now I can plug it in here, right guys? So here we go. Area in terms of X is X squared plus 4 times X. What is H now? 10 over X squared. Can I simplify that? Yep. So A of X equals X squared plus, what's 4 times 10? 40. Can I reduce one of the X's on the denominator? Yep. So that's my area in terms of X. Okay. So that's part A. If it's a closed box, that means you just have the top and also the bottom. So how many X squared would you have? 2. That's it. Okay. But it's not a closed box, it's an open box. All right, part B, what was part B?
Part B was asking how much material is needed for a square of 1 foot by 1 foot as the base.
Oh, okay. So area, if it's 1 foot, right?
Yeah.
So that's going to be 1 square. What's 40 divided by 1? 40. So how much area would we need? 41 feet square. Is that okay? What was C, dear?
It was how much material is required for a box with a base of 2 feet by 2 feet?
2 feet, okay. So that's going to be 2 squares 4, right, class? Plus 40 divided by 2. What's 40 divided by 2? 20. 20 plus 4 is 24 feet square. Okay. Yeah, I'll leave it up. Don't worry. I think there's more, right? Is that it?
Oh, it says, yeah, to graph it and then find for what value of x is the area of the smallest.
So graphing. Guys, when you're graphing, do you have to label your x and y axis?
Yes.
Yeah, please do. Okay. In this question, x axis is what? What is x?
Length of the side of the base.
Yeah, length of the side of the base. And height in this problem is area, okay, or material they use, right? Okay. Let me see what the graph looks like. Let me find. Okay, let's see. What was the equation again? It was like x squared?
X squared plus 40 over x.
X squared plus. Okay. Pinch it in really quickly. What was the window from 0 to, let's see, what's the largest x can be? Really just 3, right? The volume is how much? The volume is 10, and you have length times width times height. So at most you can have is 10, assuming the other ones are really, really tiny. Okay, like ones. Okay, so I'm gonna make it. Can you guys see that I won't need any positive x? Yes or no? How come I don't need any positive? I mean, I'm sorry, not positive. Negative x in this question. Because x is the length, right? In that number 2, you would need negative because x is x. Okay, so let's see. What is that x value? Is it 2.714? Okay, so that would be the x that I would need to give me the smallest area. Okay, and the reason they're interested in the smallest area because if you are manufacturing boxes, wouldn't you want to use less material? Okay, so that's really one of the reasons. Okay. 17, sure. All right, 17. By the way, if it's asking for x, don't put the 22, okay, unless it's asking what is the box that we need. So be careful what it wants. Okay, 22. Okay, where was I? So 26 is done. I'm sorry, what was the next question? 17? Okay. Circle. Like that? Okay.
And then it's asking for the area of the parts that are not the triangle.
Okay, so like here?
Yeah.
Okay. All right, so how do you find the area that's shaded in blue? What would you say? Area of a circle minus area of a triangle. Beautiful. Okay, what is the area of a circle, guys?
R squared.
Pi r squared. What's the area of a triangle? 1/2 base times height. Oh, did they give you what variables? What?
Yeah,
What?
side is x.
X is all the way around. Okay. Is that okay? All right. Did they give you r, or you have to find that? Are you sure? Are you positive? Go back and look. You can find it, but they also gave it to you. What was R? They gave it to you. Lena? They said r, give me the equation they gave you, Sina. Is it r squared that they gave you? Okay, r squared equals x over 3 or x squared? X squared over 3. Okay. They gave you this, right, class? You can find it. You can totally find it. But if they gave it to you, couldn't I just go and use it? If I were to go and use it, couldn't I just square both sides to find r? Okay. So, r is, what's square root of x? X. Square root of 3, there's not much you can do. But can I rationalize that? Yeah, multiply top and bottom by rad 3. So what's on the top now? X rad 3 divided by 3. All right. So right now I can go in and substitute r right away. Okay, so pi times x times rad 3 all over 3. We'll make it pretty in a little bit. Minus 1/2. What is the base for this triangle? X? Okay, yeah. Can I call that a base? And then let's make a height. Is that okay? Right there. Okay. Yes, Sarah and then Kevin.
So this is pi r squared. How can we put in r instead of the r squared?
Oh, I need to square that. Thank you. Good eye. Good job. Uh-huh.
Do you have to simplify it if you're just going to put it?
Oh, yeah. Why did I simplify that? I went that all around for nothing. Oh, you're so smart. I love you. Okay. Look at that. I went all the way around for no reason, right? All right. Can you guys see what Sarah said? And, sorry, I just went around and around and around to come back just to get that. Because pi r square, technically I can just put r square in, right? I solve r and then square it again. Oh, that's silly. Okay. All right. Base is now x. Is that okay? But what is h? I had to find it, right? Oh, Troy, thank you. All right. So h, this is h, right, class? Is this a right triangle? Let me highlight this. Like here, is that a right triangle? In a right triangle, what can you use? Pythagorean theorem, right? Okay. A square. Let's call this a square. Can we call it a square? But I'm not using it as an a variable. What variable do they use here? Half x. Yes. It's half x squared. Okay. Plus b squared. I don't have a b label. But what do we call this? H squared. Equals c squared. I don't have a c label. Well, what is this? It's x squared. Right? All rainbow. Any questions so far? And now we're going to simplify, okay? What's half square? 1/4. And then x squared is x squared. H squared is still h squared. Now what are you going to do to solve for h? Subtract. Okay, this over? Yes or no? All right, x squared, take away 1/4 x squared. Because I need to move that over. So now h squared equals what? 3/4 x squared, okay? And I need to solve a single h because according to this, there's no square h, so just h. Okay, now I have to square. So h equals, what's square root of 3? Rad 3. What's square root of 4? What's square root of x squared? X. All right, there's h. Is that okay? Now I can plug it back in, right? Minimize this. I can't pinch. There you go. Okay, so this right here, class, is your h, and it's radical 3 over 2 times x, right? Can I make that pretty? Can I make that prettier than that? Yep. What's 1/2 times radical 3 over 2? Rad 3 over 4. What's x times x? X squared. So this is the area, all in terms of what variable? X. Rita? Because you're subtracting this right here, right? You have 1x squared minus 1/4 x squared. So what's 1 minus 1/4?
Oh, yeah.
Is that okay?
For the a value, when you did the Pythagorean theorem, how did you get the 1/2 x?
Because the whole base was an x. I'm only using half, so that's why this is half
Okay.
x.
Thank you.
In the book, if they take out the x squared and factor it out.
Yes, you can totally do that. You don't need to.
Okay.
Yeah, I would totally accept factoring.
This is going to be one of the problems in the test.
Anything I give you on the homework is fair game. Okay, did I answer it? Okay, next one.
Number 9.
Well, might as well go through all the homework, right? I only gave you 4. All right. No, what's 9? Okay, so you have a rectangle?
Yeah.
Radius is 2? Okay.
Let P equal,
Shh. Guys, I can't hear Paul. He's right here.
let P equal xy.
Let P equals xy.
Be a point in quadrant.
Oh, wait, this is a coordinate plane?
Yeah.
Sorry. Make that right? So P is somewhere here? Okay, thank you.
And that is a vertex of the rectangle and it's on the circle. And it says for part A, express the area of the rectangle as a function of
Oh,
x.
dang it. Sorry. It shut down on me. Too many things open. Okay. Brenda, can you do me a favor? Go hit the keyboard and then can you go hit the button that says access? Can you see the button access? Oh, hit okay. Yeah, move the mouse all the way over. So move the mouse over, but look at this. Keep on going to the right, to the right, to the right, to the right. Keep on going. It's an extent. Keep on going. There you go. Where's it? Right here, like this. So, no, you have to look at this. It's not there. It's like a secret screen. All right, go down and click this. You have to look at this. There. Okay, hit OK. Move your mouse over, hit OK. It's like an extra secret screen that you can't see. Yeah, so move the mouse until you see it over here. Like, wiggle, move over some more of this. Keep moving. It's a secret screen that you can't see. There you go. All right, ready? Hit OK. And then hit access. And I'm going to read you like a 12-digit code. Ready? 16, 43, 24, 89, 33, 65. And hit connect for me. There you go. Beautiful. Thank you. All right. We are live. Okay. All right. Okay, Paul, go for it.
Does express the area A of the rectangle as a function of x.
Area as function of x, right? Okay, what's the area formula for rectangle, class? Yeah, so, oh, what is this? Oh my gosh, are you kidding me? All right. All right. Technology. We love them and we hate them at the same time. Right. Okay, so area is, let's try this one more time. Okay, area as a function of x, right? Okay. Girls, you can take your conversation outside anytime. Thank you. Okay, so x in this problem is what? Where is x? Can we start from the origin? Right? Would you agree that this right here is x from 0 to any point on the rectangle's x? Okay. If that's x, would you agree this is also an x? Okay. Then the rectangle has a base of how many x's? 2, right? So area of rectangle is base times height or length times width, however you want to call it. The base in this case is 2x. What is the height? Okay. So from the origin going up, what do we call that? A y, because it's unknown. Remember, this dot is here for a reason. This dot means I don't know x and I don't know how far out you're going. If that's y, from here to here is also y. So the height is how many y? Yep, 2y. Can I multiply those together? Yep, that's 4x times y. But they don't want both variables, okay? They just want it all in terms of x. So we got x. What is y and how do I get y just to solve? Didn't they also give you another equation in there? Yeah, you always have to have a second equation, okay? Whether they gave it to you or you come up with it. Is it possible for me to solve for y here? Yeah, what's y? Y squared, what did we move? 4 minus x squared, take a square root, okay? So y is just that square root, right? There's not much you can do, so leave it. Okay, so that's just a square root, 4 minus x squared. And that is the area of the rectangle in terms of x. Okay, what was b?
Express the perimeter of the rectangle as a function of x.
Okay, so same thing. So perimeter is just going to be all the sides added, right? So the bottom is 2x. The top is also 2x. How many x is that? 4x. Okay, so plus, this is, how many y's is that? Yeah, that's 2y and another 2, that's 4y. But you cannot leave y. So, what was y already that we solved? Yeah, that rad, right? 4 minus x squared. So guess what? Those are them. Okay. Yeah. Can you guys graph those and find, what are we trying to, what's our objective in graphing? Max? Okay. I'm going to graph one of them, but you should be able to graph them all, right? I want to make sure the answer is right. If you graph one of them, let's see. Okay, what was the equation for the area? 4x. What else? Times under the radical, right? So let's see, where's my radical button? Let's see. Yeah, I can't. Where's the function? Sorry, this. There you go. All right, so stats, miscellaneous, radical, and we want, was it 4 minus x? 4 minus x squared? Minus x squared. Whatever that baby said. Okay. It's not giving me anything with decimal. What's up with decimal? I think it wants power 2. There you go. All right. Now look at this. It has both positive and negative. Would I want any negative x here? Yes or no? No. How come? What does x represent in here? The length, right? Of the half the base. Okay. So if I were you, I would only have this side of the curve, okay? Then it's looking for, hey, tell me when I'm going to have the largest area. So that would be if you are, okay, so the largest x value, the x value that will give you the largest area is about 1.41. Am I correct? Is that what the book has? And the largest area is 8 units square. And I believe the perimeter should be very similar, right? You will be able to graph that out with the perimeter. They do the same thing. So there you go. All right. So today, for the remaining time, go ahead. Now we all have our own book. Joy just dropped off an extra half class set. So go grab a book, put it underneath your desk, because that's yours for the duration of the class, okay?